Hello, this is Yashvin. In this video, I'll be solving paper 4 variant 1, October number 2018, 0620 chemistry. Starting off with question number 1. The following formulae represent different substances. Answer the following questions using only these substances. Each substance may be used once, more than once, or not at all. State which substance is A, used to make food containers. So this is aluminium, since aluminium has a protective layer of aluminium oxide on its surface and it prevents corrosion. B, added to a blast furnace to remove impurities during the production of iron is calcium carbonate. The main constituent of natural gas is methane. D, a cause of acid rain is sulfur dioxide, as it gets dissolved in the rainwater and results in the formation of sulfuric acid. E, a gas which bleaches damp litmus paper. This is chlorine. F is a gas which contributes to climate change, which is again methane. Question number 2. The table gives some information about 4 different particles A, B, C, and D. A, complete the table. The first row has been done for you. Alright, so coming to particle B, you can see that the number of protons is 11. The electronic structure is also given, which if you add 8 plus 2 and then 1 is also 11, meaning that the number of electrons is 11. You can also make this out from the particle charge. Since this is 0, that means the number of protons is going to be equal to the number of electrons. And C, it has the number of electrons as 18, and as I mentioned earlier, particle charge is 0, that means the number of protons and electrons has to be equal. D, so you're now given with a number of electrons and you need to write down the electronic configuration. So the first shell has 2 electrons, the second shell has 8, and the last 8 electrons go to the third shell. And the charge on this particle, alright, is going to be -1, since the number of electrons is greater than the number of protons. There is 1 extra electron, meaning that there is going to be a charge of -1. We give 2 particles from the table which are isotopes of each other, meaning that they have the same number of protons but different number of neutrons, which are A and B. C, element Z is in the same group of the periodic table as A and is less reactive than A. Right, so first look at element A, and as you can see over here, it has 1 electron in its last shell, meaning that it is in group 1. And looking at its proton numbers, it has a proton number of 11, so it is sodium. Z is in the same group, meaning it is in group 1. State the identity of element Z. The question also states that Z is less reactive than A, and in group 1 the reactivity increases down as you go down the group. That means Z has to be above A to be less reactive, and so therefore Z is going to be lithium. D, C is unreactive. Use information from the table to explain why. So C over here is from a group 8, or is a noble gas, and since it has a complete outer shell of 8 electrons, it does not need to react to complete this. (3) Copper nitrate decomposes when heated. 2 gases, oxygen, nitrogen, and a solid are made in the reaction. So the solid over here is going to be copper oxide. A sample of copper nitrate was decomposed using the apparatus shown. 1. Complete the chemical equation for the reaction. So you have copper nitrate decomposing to form oxygen, nitrogen dioxide, and copper oxide. Alright, so you have copper oxide and 2 of these, since in the on the reactant side you have 2 of them as well, and also nitrogen on the reactant side has 2 atoms. As you multiply this 2 with this 2 and get the product as 4, and so that's how we balance it over here. 2. Only oxygen gas is collected at X. Explain why. Alright, so the remaining gas, nitrogen dioxide, is not collected, at X and they want you to explain why, and the reason is that nitrogen dioxide, being a non-metal oxide, is an acidic oxide, and so it reacts with sodium hydroxide, which is a base, and that is why it won't be collected over here, as it reacts with sodium hydroxide in the tube. B. Nitrogen dioxide and other oxides of nitrogen are formed in car engines. Explain how nitrogen dioxide is formed in car engines. So nitrogen and oxygen don't normally react together. However, they can react when at high temperatures. C. A teacher heated 18.8 grams of copper nitrate. Calculate the number of moles of copper nitrate present in the 18.8 grams. So you have the mass, you can calculate the molecular mass and then calculate the number of moles. Alright, so here you need the relative atomic mass of each of the elements in copper nitrate. So you have the formula of copper nitrate. So you have a copper atom which has the atomic mass 64, and then 2 nitrogen atoms, so you have 2 into 14. I forgot to add the plus sign over here, and then you add the number of atoms, which is of oxygen, is 16, multiplied by its mass, which is 16, and so you get the molecular mass as 188. Now you can divide mass of copper nitrate with its molecular mass, and so the number of moles is 0.1. Calculate the maximum number of moles of oxygen that can be made by heating 18.8 grams of copper nitrate. Alright, so this is where the equation comes into use, as the balanced equation states that 2 moles of copper nitrate in the equation, as we've already completed in the previous parts, gives 1 mole of oxygen. That means 0.1 moles should give 0.05, which is half of 0.01. And so this is the answer. 3. Calculate the maximum volume of oxygen at room temperature and pressure in centimeter cube that can be made by heating 18.8 grams of copper nitrate. So you have the moles, you also have the molecular volume of any gas, which is 24 dm cube, and so volume is equal to moles into molecular volume, which is 24 dm cube. But now here I'll multiply this with 24,000, since we need volume in centimeter cube and not in dm cube. So the volume of oxygen is 1200 centimeters cube. D. A sample of copper nitrate was dissolved in water to form an aqueous solution. The aqueous solution was split into 3 portions. A separate test was done on each portion as shown. Alright, so you have a few tests and their results. 1. Give the formula of the light blue precipitate formed in test 1. Alright, so in test 1 you have aqueous sodium hydroxide reacting with copper nitrate, and so this forms the precipitate of copper hydroxide, which is blue in color, and this is the answer. Alright, so I'd explain the formula over here. To write the formula of any compound, you need to separately write down the chemical symbols of the elements present. And as you can see over here, we have the copper ion and then the hydroxide ion. So here you need to know the charges. Copper has a charge of 2 plus, and hydroxide ion has a charge of -1. And now you cross them, so this gives you copper, and since it's only 1, you don't need to write that. And hydroxide ion, there's going to be 2 of them, so you put it in parentheses and write down 2. So that is how you work out its formula. To explain the changes seen in test 2. Alright, so the solution changes from blue to colorless. So the blue solution was copper nitrate, and zinc is more reactive than copper. which means it displaces copper nitrate and forms zinc nitrate, which would be the colorless solution over here. And copper metal also forms, and this brown solid which forms is going to be that copper metal. Identify two reagents that must be added to a copper nitrate test. So this test is of nitrate ion, and when ammonia is given off, that means aluminium and sodium hydroxide have been added to nitrate ion. This nitrate ion comes from the copper nitrate. So you need to add sodium hydroxide and aluminium to it. Copper nitrate can be made by reacting copper carbonate with nitric acid. One of the products is carbon dioxide. Write a chemical equation for the reaction of copper carbonate with nitric acid. Copper nitrate, water, and carbon dioxide, since this is the reaction of a carbonate with an acid. Now you need to balance out the equation. So as you can see over here, there's 2 hydrogen, and so you need to balance out the number of hydrogen, and the rest balances as well. 2 carbon dioxide is added to the air by living things. Name the chemical processes by which living things add carbon dioxide to the air. So this process is known as respiration. 3. Carbon dioxide is removed from the air by plants. Name the chemical processes by which plants remove carbon dioxide from air. This is photosynthesis, which is the reverse of respiration. 4. A sulfuric acid is made industrially by a 4-step process. So you have all of the processes given over here. 1. Some sulfur is obtained by mining. Name one major source of sulfur. So sulfur can be obtained by combustion of fossil fuels, but you only need to write the source, which is fossil fuel. 2. What is the name of the process by which sulfuric acid is made industrially? This is the contact process. 3. Describe the conversion of sulfur dioxide into sulfur trioxide. In step 2, in your answer, include a chemical equation for the reaction, the essential reaction conditions, and you need to write 5 points for the 5 marks over here. Right, so I'll start by writing the equation. So you have sulfur dioxide reacting with oxygen to give sulfur trioxide, and since this is a reversible reaction, I'll put in the reversible sign. In this form, sulfur trioxide, and then you need to balance out this equation. So this equation gives you 2 marks, one for the balanced equation and one for the reversible reaction mark. And then you need to write out all of the essential conditions. And you need the temperature of around 450 degrees Celsius, as well as pressure of around 1 atmosphere. B. When concentrated sulfuric acid is added to glucose, a black solid is produced. The concentrated sulfuric acid acts as a dehydrating agent. Since sulfuric acid is acting as a dehydrating agent, it removes the water molecules or the hydrogen and oxygen atoms from glucose, leaving it with only carbon, which forms this black solid. What is removed from glucose in this reaction, dehydrating glucose removes water from it, and the black solid which remains is carbon. C. The gas hydrogen sulfide is produced when concentrated sulfuric acid is added to solid potassium iodide. The reaction involves oxidation. One, define the term oxidation in terms of electron transfer. So oxidation is loss of electrons. To complete the dot and cross diagram to show the electron arrangement in a molecule of. Right, so sulfur has 6 electrons in its outer shell and it only needs 2 more, so it receives one of those 2 from each of the hydrogen atoms, and hydrogen as well has 1 electron in its outer shell, needing only 1 more electron. So this sulfur forms single bond with each of the 2 hydrogen atoms, and then it has its own remaining 4 electrons. Hydrogen sulfide has a simple molecular structure. Explain why hydrogen sulfide has a low boiling point. So the boiling point, it depends on the forces between the molecules of the covalent compound, which is hydrogen sulfide over here, and the forces between the molecules are known as intermolecular forces. If they're weak, that means the melting point is going to be low. So the answer is, and since this is a low melting point, that means it has weak intermolecular forces, so they don't require a lot of energy to be overcome. The dilute sulfuric acid reacts with aqueous sodium hydrogen carbonate in a neutralization reaction. In a titration, 0.2 mole per dm cube aqueous sodium hydrogen carbonate was used to neutralize 20 centimeter cube of dilute sulfuric acid of concentration 0.1 mole per dm cube. One, calculate the number of moles of dilute sulfuric acid used in the titration. So you're given with the volume and the concentration of sulfuric acid. So you need to use the formula moles is equal to concentration into volume. So you have the concentration, which is 0.15 mole, and then the volume, which is in centimeter cube. So you need to divide this with 1000 to convert it into dm cube. And this gives the answer as 3 into 10 to the power of a negative 3 moles. To calculate the number of moles of sodium hydrogen carbonate needed to neutralize dilute sulfuric acid. Alright, so first we calculated the number of moles of hydrogen of sulfuric acid, and now you need to calculate moles of sodium hydrogen carbonate. But since we're not given any quantity other than just the concentration, you can use the ratio of the equation to calculate the number of moles. And the ratio states that for every 1 mole of sulfuric acid, 2 moles of sodium hydrogen carbonate are needed for complete neutralization, and that means twice of this amount is required for complete neutralization of this reaction. So 2 times 3 into 10 to the power of negative 3 is 3. Calculate the volume in centimeter cube of 0.2 mole per dm cube aqueous sodium hydrogen carbonate needed to neutralize the dilute sulfuric acid. So you have the number of moles as 6 into 10 to the power of negative 3 and the concentration as 0.2 mole per dm cube. Now you need to calculate the volume. Volume is equal to number of moles divided by the concentration. So you have 6 into 10 to the power of negative 3 divided by 0.2, and this gives the answer as 0.03 dm cube. You multiply this with 1000 and that gives the answer as 30 centimeter cube. 5. Hydrogen gas reacts with iodine gas, the equation is shown. The reaction is reversible and can reach equilibrium. A. What is meant by the term equilibrium? Alright, so you write down the definition of equilibrium over here. Just the rate of forward reaction is equal to the rate of backward reaction, and the concentration of products and reactants remains the same at this state. B. The graph shows how pressure affects the yield of hydrogen iodide at two different temperatures. So as you can see over here from the graph, as the pressure is increasing, the yield remains the same. The difference is due to the temperatures. So a higher yield is obtained at lower temperature of 500 degrees Celsius and higher temperature of 700 degrees Celsius gives a lower yield. One, explain why the yield at 500 degrees Celsius does not change as the pressure is increased. Right, so pressure only affects the equilibrium if the number of moles is different on both sides. However, as you can see over here, there's 2 moles of products and 1 mole of the two reactants, which makes up a total of 2 moles of reactants on the left hand side, which means the number of moles balances out. So equal number of moles means there is no effect of pressure on the equilibrium yield. Two, what can you conclude from the differences in the yield of hydrogen iodide at two temperatures shown? Explain your answer. Right. So as you can see over here, as already mentioned, a higher temperature provides lower yield of hydrogen iodide. And that means if the lower temperature provides a greater yield, that means the reaction, which is the forward reaction producing the yield, would be favored by low temperatures, or in other words, exothermic. So you have the answer. The forward reaction is exothermic as it is favored by low temperature or gives a high yield at low temperature. See, the graph shows how the concentration of hydrogen iodide changes after hydrogen gas and hydrogen and iodine gas are mixed together in a sealed container. Alright, so you start off with hydrogen and iodine as they react. The concentration of hydrogen iodide, which is made as the product, increases until it reaches equilibrium and remains the same, at which point the concentration of hydrogen iodide, which is the product, and the reactants remains the same. One, when is the rate of the reaction fastest? It's fastest at the beginning, and the rate of reaction is also represented by the slope of the curve. As you can see over here, it is the steepest at the beginning, and the steepness decreases as the reaction proceeds. So that means the reaction is fastest at the beginning. Two, the reaction was repeated at the same temperature and pressure but in the presence of a catalyst. Draw a graph on the same axis to show how the concentration of hydrogen iodide changes with time in the presence of a catalyst. So a catalyst increases the rate of a reaction, meaning it would be steeper at the beginning and it would reach equilibrium faster, and the final volume of hydrogen iodide would remain the same. D. A mixture of hydrogen gas and iodine gas is allowed to reach equilibrium. Increasing the pressure of a gas increases its concentration. State and explain the effect of increasing pressure on the rate of forward reaction. So as you increase the pressure, the molecules come closer together, which means the concentration of molecules per unit volume increases, and if the molecules are closer together, their collision frequency would increase, which would result in increase in rate of reaction. To state and explain the effect of increasing the temperature on the rate of reverse reaction. Alright, so the reverse reaction is endothermic in the equilibrium. That means the position of equilibrium would be shifted to left if you increase the reaction. However, here they're only asking about the rate of reaction, so you don't need to mention the equilibrium and just the rate. And rate of any reaction, be it endothermic, and rate of a reaction would be increased by increasing temperature. And here you need to write down why that is so. So increasing the temperature increases the kinetic energy of molecules, since the two quantities are related. And due to this increase in kinetic energy, molecules move faster and they collide more often. Also, more molecules would have energy that is greater than the activation energy. And only molecules that have energy greater than the activation energy can react. And if more molecules have energy greater than the activation energy, that means more molecule collision result in reaction being successful. So you have the answer as rate of reaction increases. And a greater proportion of molecules has energy which is greater than the activation energy, which leads to successful collisions. Ethane is a member of homologous series called alkanes. Ethanol is a member of homologous series called alcohols. Alkanes are hydrocarbons. What is meant by the term hydrocarbon? So you write down the definition of hydrocarbon, which is there is only hydrogen and carbon atoms in the compound, which is a hydrocarbon. All members of a homologous series can be represented by a general formula. State the general formula of alkanes. So that is CN, which representing the number of number of carbon atoms, and H2N plus 2, which is the number of hydrogen atoms. And alcohols have the formula CnH2n plus 1. And OH. 3. State two characteristics other than having the same general formula of members of a homologous series. So they have the same functional group, and they also have trends in their physical properties. B. Ethane can react with chlorine in a substitution reaction. One essential reaction condition. So this one condition is presence of ultraviolet light. To draw the structure of organic compound formed by substitution of one of the hydrogen atoms in ethane with chlorine. Show all of the atoms and all of the bond. So start off with ethane, which has 2 carbon atoms and 6 hydrogen atoms. One of hydrogen atoms would be replaced by chlorine, which has 5 hydrogen atoms, 1 chlorine atom in any position of the hydrogen atoms. 3. Name the product of the substitution reaction between ethane and chlorine that does not contain carbon. This is the organic product, and the other product is hydrogen chloride, which does not have carbon. C. Propanol is an alcohol. Propanol is an alcohol. The structure of propanol is shown. Propanol reacts with ethanoic acid to form an ester, give the name of the ester produced in this reaction. So you name ester with the name of the alcohol first and then the acid. So you have the ester would be named as propyl ethanoate, the ethanoate from the acid and propyl from the alcohol. The ester Y has the structure shown. 1 give the molecular formula of the ester Y. So you write down the number of the element symbol and their total numbers, and if you count them you'd have 5 carbon atoms, 10 hydrogen atoms, and 2 oxygen atoms. To draw the structures of the carboxylic acid and the alcohol used to make ester Y, show all of the atoms and all of the bonds, give the name of the carboxylic acid and the alcohol. Alright, so if you can see over here, this is the ester bond with the this part has come from the acid, and since this only has 1 carbon, that means the acid would have been methanoic acid, and this part which has come from the alcohol has 4 carbon atoms, which means the alcohol would have been butanol. So you draw out their structures. The acid would have been carbon double bonded with oxygen with hydrogen on one side and a hydroxyl group on the other side. This part of the alcohol reacts with the acid to form the ester, and this hydroxyl group gets removed. But in its alcohol form, this hydroxide group is bonded to the second carbon position, since this is the first one, second one, third one, and the fourth one, and that is why you name this alcohol as butane 2-ol, depending representing the position of the hydroxyl group. And the acid is methanoic acid. E-nylon is a polyamide. Complete the diagram to show the structure of nylon. Show all of the atoms and all of the bonds present in the linkages. So you start off with the 2 monomers that are a dicarboxylic and diamine. So this one over here is the dicarboxylic, and then we have the diamine with an amine group, sorry, 2 amine groups. Right, so the hydroxyl group of the acid part and hydrogen of the amine react together to form a bond, and this results in the production of nylon. So this part gets removed over here, and I'll be using the gray block to represent the carboxylic group. You can use this as not the amine group or the carboxylic group, doesn't matter which you choose, but they all have to be, they then have to repeat the same pattern. So we have a carbon over here and it extends the link. Then we have another carbon with its double bonded oxygen, and now since this bond breaks, since a water molecule is produced over here, a bond forms between this carbon atom and this nitrogen over here. So you have nitrogen and one of the hydrogen atoms of nitrogen remains, and that is how this is repeated along the length of the polymer. A hydrogen atom over here, and that is it.